Guys, my name is Elishiraj and I would like to talk about single electron transistor. So starting with the outline, I will talk about history, why we need single electron transistor, difference between SCT and MOSFET, and then we have fabrication, working, and at the end I would like to talk about applications. Okay, so what is the history of transistor? Three scientists named as a Shockley, Brattain, and Bardeen, they invented the information age of the transistor, and then there comes Moore's law. Moore states that number of transistor lying on IC chip, they gets doubled after every 2 years. So we can see the comparison between 1962, 1965 and 1970. So it's a clear indication that Moore's was right. Okay, so why we need single electron transistor? As the world is heading towards a miniaturization, so bulk is replacing by atoms, molecules. So here there comes single electron transistor, which will use only one single electron in order to have the conductance. So why we need single electron transistor? It's about the power consumption challenge. It's a very low power consumption device, and it's very high performance, high density chip design, and fast information processing. So difference between SCT and MOSFET, only we have quantum dot instead of having channel, unlike in the traditional MOSFET, and then we have island consisted of aluminum, gallium arsenide, and some other gallium arsenide sources. We have drain, source, and confining electrons, and at the end, at the upper part, we have gate. Okay, so we have two major phenomena which will contribute towards the conductance and operation of the single electron transistor. First of all, we have Coulomb blockade, which will explain about how when an electron tunnels through a potential barrier, and it will explain the decrease in electrical conductance at small bias voltages of single electron transistor with the tunnel junction. And then we have Kondo effect, which will talk about the scattering of conduction electrons I mean, in a system due to magnetic impurities, which will change the electrical resistivity with temperature. So it's all about the magnetic impurities in the system. And then we have a fabrication, V-PADOX, vertical pattern dependent oxidation. So here we have thick silicon. This is actually a transmission electron microscopic images. We have thick silicon, and after some kind of oxidation parameters, they have this silicon island at the both ends of the silicon wires. These are very clear islands. So here they have shown the conductance with respect to the gate voltages at 300 Kelvin and drain to source voltages at 1 millivolt. And then this is a schematic. They have fine trench, drain, source, buried oxide, silicon substrate. So this is a very fine schematic of the single electron transistor. Okay, so at the end I would like to talk about some microwave applications. Why single electron transistor is very important in the industry? It is because of the microwave detection, photon eddy tunneling, quantum computers, which are very fast, 1000x faster, super sensitivity, electrometry, radio frequency, single electron transistor. So this was a little introduction of the single electron transistor. It's a very useful gadget. Hope you like it. Thank you so much.